Welcome to The Explainer. Today, we're going to talk about the mechanics, and really, the magic, behind some of the most common robots you see everywhere, both on our planet and even off of it.
Okay, so let me start with a question for you. Think about a Mars rover. One of those autonomous carts zipping around a massive warehouse, and yeah, even that little robot vacuum that cleans your floors. What do they all have in common? What's the one piece of technology that ties them all together?
Well, the answer is actually super simple. It's the wheel. They are all wheeled mobile robots. And you know what? These things are the absolute workhorses of the robotics world. So today, let's dig in and see what really makes them tick.
So at its most basic level, a wheeled mobile robot is, well, it's pretty much what it sounds like. But why wheels? Why not legs or something else? It really comes down to this. They are just so incredibly energy efficient and way easier to control, especially when you're on a flat, predictable surface. You know, like the floors in a factory, a hospital, or even your own living room.
Okay, so we know they roll, but how do they actually move? I mean, how does a robot turn a tight corner or just spin right there in place? All right, let's get into the blueprint for how this all works. It all comes down to the way they're designed from the ground up.
You'll see two designs pop up all the time. First, there's the differential drive. Literally, that's what your robot vacuum uses. And then you've got the more stable four-wheel drive, which, let's be honest, is pretty much a tiny car. And each one is built for a very specific job.
And what's so fascinating is how this one simple design choice changes everything. A differential drive robot, it turns by making one wheel spin faster than the other one. That's it. And that simple trick lets it turn on a dime, which is perfect for navigating a cluttered living room, right? But the four-wheel design, that's all about stability. It's for carrying heavy loads, just like your car. This really gets to a core idea in robotics. Are you building a specialist that's amazing at one thing, or a generalist that's just okay at a lot of things? It's that classic engineering problem. Do you choose agility or stability?
Okay, so we've got the legs figured out. We know how they move. But how do they know where to go? This is where we get past the simple mechanics and into the robot's senses and its brain. We're talking about intelligent navigation.
So imagine you're a robot in a brand new room. You've got this classic chicken and egg problem, right? You can't make a map of the room if you don't know where you are. But you can't figure out where you are if you don't have a map. So what do? Well, there's this brilliant solution, an algorithm called SLAM. What it does is amazing. It lets the robot draw the map and put a "you are here" pin on it at the very same time. It's such a cool way to solve that core challenge of navigating on your own.
So let's break down how that actually works. It's this constant, super fast feedback loop. First, it senses the world around it with things like lasers or cameras. Then it maps all that information into a digital layout of the room. After that, it plans the most efficient path to get where it's going, avoiding that coffee table or the shoes you left out. And finally, it acts. It translates that plan into precise instructions for its wheels. Sense, map, plan, act. Over and over and over again. That's how it can adapt to changes in real time.
And really, that combination of super efficient movement and smart navigation, that's exactly why these robots are popping up everywhere. So let's take a look at where they're being put to work in applications you probably see every day. I mean, in logistics, you've got these AMRs, autonomous mobile robots, that are just completely changing how warehouses operate. In hospitals, they're zipping around delivering medicine and supplies, which frees up the nurses and doctors to do more important things. Then, of course, at home, they're doing our chores for us. And how can we forget space exploration? Rovers are literally our eyes and hands on places like Mars, navigating these incredible alien landscapes.
So, if there's one crucial point to take away, it's this. Wheeled robots have become the absolute backbone of modern automation for one simple reason. They have completely mastered the flat world. Their simplicity and amazing energy efficiency just make them the most practical, logical choice for almost all of the structured environments where we actually need robots to work.
But what about the rest of the world? The world that isn't a perfectly flat, polished floor? What happens when these robots go off-road, so to speak, and leave the factory behind? Well, that brings us right to their biggest limitations.
Yeah, for all the amazing things they do, wheels have some pretty clear weaknesses. Think about it. They need to stay in contact with the ground. So if you put them on soft sand or a rocky hillside, they're going to struggle. Big time. And climbing stairs or trying to get through a messy debris field? Forget about it. It's often just impossible. And that's why, for the really, really tough terrains, engineers have to start looking at totally different solutions, like robots with legs or tracks.
Which kind of leaves us with this final big question. Wheels have conquered the flat world, the structured world that we humans have built for ourselves.
So the next great challenge, the next frontier, is building robots that can go everywhere else. What's it going to take to conquer the rest of the world? Is it hybrid designs that have both wheels and legs? Some kind of new materials? Or just smarter, more adaptable AI? That's the question that's really driving the next generation of robotics. Thanks for joining us for this Explain.